Welcome. So we're going to answer this question before us. Let's give it a read and see how we go. It says that we need to sketch this graph here. Here is our domain, showing all axis intercepts in exact form and endpoints. First thing first, let's state the amplitude and the period here. So the amplitude is very easy to read off. It's just what it's in front. And remember, it's always going to be a positive number. The period is also an easy one. You just go 2 pi over whatever your coefficient of x is. And here your coefficient of x is a half. So that means the period is going to be 4 pi. Now, what makes this interesting is that the period is 4 pi, but my domain is 0 to 2 pi, which means I'm not going to be able to fit one complete period inside my domain. So I'm not going to get a full sine graph here. I'm going to get half of one, and we'll see what this looks like soon. All right, the next thing I would want to do here is just kind of situate myself a bit. So I know that I have a translation of -1 down, so that means it's going to be centered at here. Then I've got -1, I would have -2, I would have -3. This is going to be 0. This is going to be 1. This is going to be 2. Now, I'm going to be centered right here at -1. And if we can just, I wouldn't draw this in, but just kind of show you what we're thinking of. Because the amplitude is 2, that means I'm going 2 up, I'm going 2 down. It's going to look something like that. That's what we're drawing. Now, but we know that this is 4 pi, right? And my domain is only to 2 pi, so it's actually going to just be to there. It will just be half of it. But of course, we can't just draw it roughly like that. We need to figure out x-intercepts. So before we jump into this, let's figure out some x-intercepts here. So remember, the way in which you find x-intercepts is to find x-intercepts, you let y, that's a funny looking y, you let y be equal to 0. So that means I'm going to set this equal to 0 and get 2 sine of x on 2 minus 1, which is going to be, and I also need to consider this over the domain, which is 0 to 2 pi. We do a bit of rearranging. This is also an important step, a very important step, when you recognize that whenever you're given something like this, so you have a coefficient in front of your x that's other than 1, you need to modify your domain. So that means I'm going to have to come here and times this by a half, which means I times this by a half and I times this by a half. So this is x on 2 is an element of 0 to pi. Okay, now that I've done that, I now need to solve this. So remember, what you want to do is you want to find your reference angle. You consider our special triangle here. This is square root of 3, 2, 1. If I want to find sine of 1/2, that will be here, here. Sine is opposite of hypotenuse, so this is going to be pi on 6. So that means my reference angle is pi on 6. You also need to figure out for which quadrants this exists. Sine is my y. A half is positive. It's up here. I'm going to be in my first and my second quadrants. So that means I'm going to end up with x on 2 is equal to pi on 6 in my first quadrant is just pi on 6. And then in my second quadrant is going to be 5 pi on 6. And that's it. Because remember, my domain is 0 to pi. There's 0. There's pi. I don't consider anything more. Because otherwise I would be going past my domain. There's 0, there's pi. I can't consider anything more. So that means the last thing we need to do now is just get everything in terms of x by itself. So that means I'm going to times this by 2, this by 2, and this by 2 in order to achieve that. So that means that 2 will go away. And what I'm going to end up with is x is equal to, now this is just going to cancel. That will become 3. So this will become pi on 3. And this here will also cancel. This will become 3 and 1. So this will become 5 pi on 3. Okay. So having now done that, we've got our x-intercepts here. So here they are. We've got our x-intercepts. We now just need to plot this on. Now, I know it's pi on 3, 5 pi on 3, and so on. So if we kind of think about this for a second, if this is pi on 3, 2 pi on 3, 3 pi on 3, so this would be pi, 4 pi on 3, 5 pi on 3, 6 pi on 3. So 1, 2, 3, 4, 5, 6. This right here is going to be 2 pi. Okay, so I'm going to go up like that. Oops. Up like that. Oh, it's really hard to sketch on this thing because I can't see past one side of my hand. Okay, That is terrible. Hopefully you're having more success than me. My apologies. It's really quite tricky to sketch on this tablet. Well, that's the excuse I'm using. I just want to go through this point, go up, then go through that point and go up. Yeah, that's a better way to do it. It should be smoother. It should be smoother. You should have a nice smooth curve to it. They do care in year 12 that you have a nice smooth curve. That's too pointy, but whatever. This point here is pi on 3. This point here is 5 pi on 3. Hopefully you can see what I've done here. This point here would be 6 pi on 3, right? Which is 2 pi. This point here would be 3 pi on 3. So I've spaced this out nicely so it all makes sense. This point here would be pi 1. This point here is going to be 2 pi negative 1. And that's it. So as you can see, because we've got this restricted domain, my domain is from 0 to 2 pi. We're stopping here. I don't continue along. So I'm not getting that full sine curve because I'm only considering this part right here. So I've just got pi on 3, 5 pi on 3. I've labeled my endpoints. Let's label this point as well. Let's call this 0, negative 1, just to be safe. Is there anything else I need to label here? I've got my axis intercepts labeled, this, and I've got my endpoints labeled, this. I'm all good. Technically, I don't need to label this maximum, but I've done it anyway, just to be safe. And that's it. It doesn't say that I need to label my intercepts with coordinates. So the fact that I've just called this pi on 3 and 5 pi on 3 is fine. And that's it. All right. Hopefully you found this helpful in how to approach this question. We'll see you in the next one.